So, who's ready for a warm up? We talked about this already. Decompose means to break up into the two separate functions, into f and g. Now, I have to make sure that the directions are given. Okay, so f of g of x. G of x is the little guy, and f of x is the big guy. So let me go ahead and write the official problem here. So h of x is equal to, here's a good example, 2 times the square root of x plus 3 all over 5. Okay, I have to follow the directions because f is the big guy and g is the little guy. So let me just get my work all labeled. F of x, g of x. So I have to find a little guy who's inside of the big guy. So while I'm looking at this, you have to find something that has all the x's. So I'm going to put a circle around this stuff right here. I'm going to say that that quantity, x plus 3, was the little guy. And that went into the big guy, into f of x. So what's left? Whatever you circle, whatever you take out, has to be all the x's. Okay, you're going to call that x. So the big function is 2 times the square root of over 5, and you're going to call that x. And there's a really easy way to see if you did this right. We can go ahead and compose f of g of x. So I think f of g, the little guy, x plus 3, has to go into f. And if that goes into f, let's see, f says 2 times the square root of input all over 5, and my input is x plus 3. Is that right? It is. I decomposed it. Some people can just plug it in their mind or with their finger, plug it in and check that way. But I'll tell you that the biggest mistake people make on the test is switching the big guy with the little guy. Now, there's more than one way to decompose. You don't have to have all these answers, but let me show you another one. F of x and g of x. So what if the little one was all of this stuff, was the radical and the quantity x plus 3? So if all of that gets taken out, sometimes I just cover it up with my thumb. If all of that is the little guy, what's left? 2 times that stuff, which you always say as an x, over 5. So whatever you take out, you call x. Is that right? If this quantity goes into that spot, I think that would work. There's lots of ways to decompose. You just have to make sure that you make one way. Okay, here's another example. What if they told us h of x was the absolute value of 1 over 4x minus 7? Okay, let's see if we can figure out how it was composed. First, I have to read the directions. Notice here, f of x is the little guy. So g of x is the big guy, and f of x is the little guy. So look at the problem, and you have to grab all the x's. I'm going to grab this whole quantity here. I'm going to say that f is the quantity 4x minus 7. So whatever you take out as the little guy, you're going to call x in the big guy. So what's left? G has to absolute value, and he has to say 1 over input. And you say x is the input. If this quantity goes into the big G right there, I think that would work. But that's not the only way to do this, of course. Let's show you another example. What if the little guy was this entire quantity? What if it was 1 divided by 4x minus 7, the whole fraction? So if that whole thing is the little guy, and that has to go into g, what does g say to do to all that stuff? Absolute value it. And you put x for whatever you took out. Okay, the more you compose, the better you'll get at decomposing. Here's a little review of something we've done before, but students usually need a little bit more help with it, so let me help you one more time. They want us to compose f of g of x. So the first thing I'm going to do, is write f of, And I'm going to put the g of x function into the f function. G is x plus 4 over 2x minus 5. Okay, that entire quantity has to go into f. Now what does f say? The f function says, wow, huge fraction. He says 2 times input minus 1. Okay, let me get ready for that. 2 times input minus 1. And the denominator has to be input minus 2. Input minus 2. And the input is this fraction, x plus 4 over 2x minus 5. X plus 4 over 2x minus 5. Okay, remember how I said to deal with something like this? You cannot just start finding stuff that matches. This is an entire quantity in the numerator as well as the denominator, and so I'm going to multiply top and bottom by 2x minus 5, the denominator. Okay, and we're going to have to distribute it in. So when I distribute it to this first term, the quantity cancels, and we get 2 times the quantity x plus 4. Then we're going to distribute it there and say minus the quantity 2x minus 5. Some negatives are coming up. In the denominator, we're going to distribute it to that first fraction, cancel it away, get x plus 4 minus 2 times the quantity 2x minus 5. And now it's just time to clean things up. Let's see, 2x minus 2x, that's going to cancel. And 8 plus 5 is 13. The denominator, distribute, is going to be 5x plus 14. And I want to label my answer, of course, as f of g of x. So there's just a little bit of review of what to do when you have those huge fractions. Okay. What are we doing today? We're going to find the domain of composed functions. Okay, and this is not like any domain you've done thus far, so you really need to pay attention to the difference when the functions are composed. Okay, since it's f of g of x, this is a little different. The g function is going into the f function. Does x go into f? No, x does not go into f. X goes into g. So there's two steps. Okay, step one. Step one is find the domain. Find the domain of the little function. So in this case, you have to find the domain of g. What x's are allowed into g? And that's normal stuff, how we find normal domain. But then there's step two, and this is where it gets funny. The little function goes into f. So then we have to make sure that the little function g obeys the domain of f. If f says, I don't like negatives, then the g of x function cannot be negative. So step two is that the little function must obey the big function. And I'm saying big and little because sometimes it's f of g and sometimes it's g of f. So since g is going into f, the little function g must obey f. Okay, does that make sense? So there's two steps. You cannot do these problems like you've been doing all the other domains. You have to make sure that we do this. The neat thing about this is you don't actually have to compose to find the domain. You don't actually have to compose. It says find the domain for f of g of x. Okay, I'm going to follow the rules here. So domain. Okay, step one. Find the domain of g. So let's look at g. This is a really easy one. He doesn't have any radicals, no fractions. The domain is all reals. Great. Okay, step 2. G is going into F. G must obey F. Let's go see if F has any restrictions. F says, I like all real numbers. G, can you obey that? Pretty sure he can obey all reals. So step 2 answer is all reals. Okay, now I have to combine these for the overall answer. This is kind of silly. All reals and all reals, survey says the domain is all reals. Okay, now that's a super easy one. We're going to get into some juicier ones in just a second, but you have to follow the 2 steps like that. Okay, let's do another one. Okay, let's look to see what they want us to find, and it's the domain for F of G. Okay. Sometimes what I'm doing is I like to just write the domains up here. That way, as I start to do my work, it's a little easier. The domain for G, that's all reals. And the domain for F, x has to be greater than or equal to -2. Okay. All right, here we go. We're going to follow the rules for the domain. Okay, step 1. You look at the little function. The domain for G. I already thought about this answer, and it's all reals. That one was nice. Now, step 2, G goes into F. G must obey F. Does F have any restrictions this time? Yes. F wants numbers more than or equal to -2. Okay, we have to make sure we do some work here, so we have to make a problem. G must obey F. G of x must obey F. So what is the G of x function? Well, he's right there. G of x is 4x plus 1. And what does F say? We want to make sure that we obey him. F says more than or equal to -2. So this equation right here has to be more than or equal to -2. Here's G of x, and here's F saying what he will allow. After you make the math problem, you just have to solve it. So 4x greater than or equal to -3. X's have to be greater than or equal to -3/4. Now it's time to put these 2 concepts together to say the actual answer for domain. Okay, part 1 says I like all numbers. But part 2 will only work if you're greater than or equal to 3/4. You want to make sure everybody works, so we're going to say x is greater than or equal to -3/4. So you state the one that's more restrictive. I know G will work with anything, but F won't work if there's certain numbers plugged into him. And who's going into F? G. So G had to obey the rule that F was saying. Okay, you don't actually have to compose them to find this answer. Let's do some more so we get the hang of this. Okay, state the domain for F of G. Okay, F of G of x. So there's 2 parts. Step 1, you have to look at G of x. You know what I like? I like to write the domains up here just so that I have them to reference. So if you look at G real fast, the G of x function says x's cannot equal 1. And what does F say? F domain says x's cannot equal -2. The biggest mistake you can make is just to take these 2 answers and write that down. That's the old way if they were separate. But now that F of G of x is being composed, we have to compose the domains. So step 1, what's the domain for G? We already thought about it. X's cannot equal 1. Okay, step 2, G of x is going into F. So G of x must obey F. So let's write down the G function. Let's write down 4 over x minus 1 has to obey F. F says don't you equal a negative 2. Okay, do not equal negative 2. Here it says x can't equal 2 because x is going in, but here g is going in, so g cannot equal negative 2. Since this is an equal sign problem, you can cross multiply. So we'll cross multiply here. 4 cannot equal 2. Distribute the negative. Negative 2x plus 2. 2x cannot equal negative 2. X cannot equal negative 1. Okay, it's time for us to put these two parts together. So the answer for a domain. All reals except x cannot equal 1. X cannot equal negative 1. I think I'll just write plus minus 1. Do you see how the answer for the composed is not the answer for f and g? Okay, that the composed domain is going to be a separate domain answer. All right, let's try this next one here. We have to do g of f of x. So there's two parts. Okay, part 1, domain of the little guy. The domain of f, I have that answer somewhere. X's cannot equal negative 2. Now step 2. Step 2. F of x must obey g. F of x is going into g. So f has to make sure that he works when he goes into g. So let's translate this sentence into mathematics. Let's write the f function down. 1 over x plus 2 has to obey g. Does g have any restrictions? Yep, he says do not equal 1. I will not work if you put a 1 in. So do not equal a 1. We're going to solve this by cross multiplying, just like the last one. X plus 2 cannot equal 1 times 1 is 1. X cannot equal negative 1. So let's put these two steps together for our domain answer. Okay, all reals except x cannot equal negative 2 or negative 1. Please don't try to find a different way. I found a nice easy way of doing this, and it works half the time because that's not going to work. Okay, this example wants us to do a little bit of extra work. They want us to find f of g and find the domain. Okay, let's make sure we read the directions for these problems. So first, we have to find f of g of x. F of g of x. So first I want us to do some composing work. Okay, so g has to go into f. So let's write down the big F, and let's write down the g function. Square root of x minus 2. That has to go into f. What does f say? Square your input and add a 4. Okay, square the input. My input has to get squared and then add a 4. A square root will cancel, and I get x plus 2. So f of g of x is right here. Now I look at this, and it looks like there's no problem with the domain, but that's not how you do it. To state the domain of a composed, you have to consider the steps. F of g of x. Okay, step 1, the domain of the little guy. So let's look back up here at g. X minus 2 has to be greater than or equal to 0. So x's have to be greater than or equal to 2. All right, step 2. The g of x function is going to go into f. So g of x must obey f. So let's write down the g of x function. Square root of x minus 2. Does f have any restrictions? Oh, no, f is fine. F will allow in all reals. So he has to obey all reals. This is just going to be all reals. He has to obey all reals. That's fine. He will allow in anything. F is allowing anything. All right, so let's put these two together for the overall domain. X is greater than or equal to a 2. Okay. And the next one, we have g of f of x. All right, so let's compose. Let's find the composition, and then we'll state the domain. So we have to do g of f. Let's write the f function in there. F is x squared plus 4. G, what does G say? He says square root your input minus 2. Square root your input minus 2. And the input is x squared plus 4. Let's add the numbers first. X squared plus 2. And you cannot square root. This is a quantity. Nobody can come out. So g of f of x is going to equal this expression right there. Okay, now let's state the domain. Okay, step 1. We have to find the domain of the little guy. Domain of f is all reals. That's nice. Now step 2. F of x, the little guy, goes into g. F must obey g. Does g have a restriction? Yeah, g has a restriction. It said you have to be greater than or equal to a 2. So we're going to have to do a problem here. So let's write down the f function, x squared plus 4. And g says be greater than or equal to a 2. Okay, let's go ahead and solve this. Maybe I'll move everything over here to the left. X squared plus 2 is greater than or equal to 0. I'm having trouble factoring with a plus. If I take a look at x squared greater than or equal to negative 2, do you remember what this means here? X's have to be greater than a negative 2 when they get squared. Positives will be more than a negative. 0 will be more than a negative. Negatives get squared. Remember? It's all reals. Okay, so to state the answer, we have to combine step 1 reals with step 2 all reals. So the overall answer is all reals. Okay. We got one more. Find f of g and the domain. Okay, so there's only one part here. First, we'll compose f of g of x. The first thing I'm going to do is write f of and put the g of x function in there. The g of x function is the square root of x plus 5. Now let's take a look at f. F says 1 divide by input. 1 divide by input. 1 divide by the input is square root of x plus 5. You could leave it like that. I think I'll accept either answer. If you wanted to rationalize by multiplying by top and bottom by the radical, you could also write the square root of x plus 5 over regular x plus 5. I'll take either answer here. And now it's time for the domain. Before I start the domain, I want to go up here and write down the little domains for these guys. That makes my work a little faster. This says do not equal 0. And this says be greater than or equal to negative 5. Okay, let's do some domain work. Domain work. Step 1. The little guy is g. So we write down his domain. X's have to be greater than or equal to negative 5. Gotcha. And then we have to consider step 2. Since g goes into f, g of x must obey f. So let's write the g of x function down. Square root of x plus 5. Does f have any restrictions? Yes, he says do not equal a 0. Do not equal 0. Since this is an equal sign, not equal and equal have the same rules, you're allowed to square both sides. Put big parentheses. The entire radical squared is just the quantity x plus 5, not equal to 0. X cannot equal a negative 5. So now I'm going to combine these answers for the overall domain. This is kind of weird because they're both negative 5. He says be greater or equal to negative 5, but this one says I don't want you to equal a negative 5. So I guess if I put them together, x's are going to have to be just greater than negative 5. Thank you.